Hello everyone, this is Team Whatever giving presentation for module Data Mining and Text Analytics. In this video, we are going to talk about a project about offensive language detection in tweets. The object of this project is to propose a solution for the task 6 of Samuel 2019 challenge, which is identifying and categorizing offensive language in social media. Offensive language is pervasive in social media and online communities. Technology companies have been investing heavily in ways to cope with offensive language to prevent abusive behaviors in social media. Here, a categorized dataset of collected tweets is used for exploration. First, let's take a look at the data structure. We can see that there are 5 attributes, ID being the ID, and tweet is a short text on Twitter. Subtask ABC are categories of tweets. There are different classes for each subtask. The overall quality of this dataset is good. There are no misses or duplicates found in the dataset. Also, all data were encoded and formatted in the same way. However, we've spotted some issues that could potentially affect our data exploration. First, irrelevant attributes. For example, for subtask A, attribute subtask B and C is irrelevant to our objective, or vice versa for subtask B and C. Polluted content is the second. Tweets are polluted in different ways that may affect the accuracy of classification. Syntaxes that doesn't affect offensive sentiment classification like question mark and emojis. Third is indistinguishable null value. For example, in subtask C, null value could be untargeted or not offensive, but we couldn't distinguish them unless we combined it with other columns. Multiple existing tools and techniques were used for data preparation. Techniques like pandas and Python were applied to convert the original TSV file to CSV file, and Weka has built-in library called CSV Loader that enables Weka to read files in CSV file format and convert to ARF files. And we remove unnecessary contents from tweets, and all letters were converted into lower cases, since letter cases barely affect the offense. And we convert data encoding to NSI. Then we combine classes for subtask B and C, and we select different features from the dataset for different tasks.
Now we are turning to the modeling part. The classifiers we choose to use are Bayes-Knight random forest and naive-Bayes multi-nominalized. The filters we choose to use are string-to-word vector and resemble with random seed equals to 10, and the odd test options are 10 for the cross-validation. In method 1, the filter we choose to use is string-to-word vector and resemble with random seed equals to 10. And the classifier choose to use is Bayes-Knight and task option is 10 for the cross-validation. Here is the result of subtask A and its accuracy, and the result of subtask B and its accuracy. In method 2, the filter we choose to use is string-to-word vector, and the classifier we choose to use is random forest. Also, the test option is 10 for the cross-validation. Here is the result of subtask A and its accuracy, also the result of subtask B. In method 3, we didn't use any filter, and the classifier we choose to use is naive-Bayes multi-nominalized, and also the test option is 10 for the cross-validation. Here is the result of subtask A, and here is the result of subtask B and its accuracy. Here is a list of results. We will talk in detail in the next part.
This is the list of 5 variables which are used to evaluate models built from 3 methods. As shown in this table, method 2 has the highest accuracy among 3 methods, that is method 1. By comparing the accuracy of these 3 methods on subtask A, but on the ratio of precision and recall, method 2 has the lowest recall ratio, and method 1 are balanced on these 2 variables, which indicates that it is more efficient than the other 2 methods. In terms of the performance on subtask B, accuracy of Method 1 has the highest accuracy, while Method 3 has the poorest one. Method 1 still has the most balanced performance on both precision ratio and recall ratio, followed by Method 1. Method 2 are also balanced on precision ratio and recall ratio. Similarly, among 3 confusion matrices, Method 3 has classified the most correct data labeled and targeted. Overall, method 1 is the best classification method, whatever it is used to classify the data of subtask A or subtask B, and method 2 is the second choice. As for method 3, it still could be used to classify data on subtask A, but it is not suggested to use method 3 to classify data of subtask B because of its low accuracy on subtask B. That's all about our presentation. Thanks for listening.